I do apologize for the clickbait, but I found it's a very easy way to get your talks accepted into conferences. So if you really want to do a conference, always go for a clickbaity title. So the title of this talk was Convincing ITs that our packages are safe. There's a lot to unpack there, and I'll give you the unofficial title in a bit. You already saw this. This is Colin makes me add this to every presentation. So, but I'll just talk a bit about me. So like Colin said, I joined Jumping Rivers about 6 months ago. I have been an R and Shiny developer for a lot longer than that. I think it's a bit over 6 years now. And before that, I was also a web developer for a long part of my life. I used to be the guy that made the website that you would see somewhere. Some of you might have been in the responsive workshop yesterday. You might remember me just saying how bad life used to be as a web developer. Now it's easier. I'm also an open source contributor, so a lot of the stuff that I learned in web development, I kind of try to move into R. If you check any of those packages, I consider checking the Raccoon one. It's actually a very fun one. You can look for any X sticker for any package on cron, and it will do its best to find you a good looking sticker. Okay, so convincing IT that our packages are safe is a really nice clickbaity title, but what do we actually mean by that? Very often if you work with in a company that has some kind of IT security, it's never that easy to get IT to actually accept the things that you want to use. They have concerns about security, stability. Why are you installing this low-level library? Why do you need this? This is going to take so much space. Is this actually safe? There's not a lot of ways that you can actually prove IT that something is okay to use. It's fine to use it. Here's all the details. Here's all the stuff. This has been used for a long time. There's also not a lot of good practices for risk mitigation. Like if you really need a specific piece of software, can you somehow make it more stable? Can you somehow make it more safe? Is there anything that you can tell IT that will make them feel a bit more at ease and actually let you install the package that you actually want? So this whole thing kind of started exactly with a story like this. So it started with a client that came to us and kind of started asking how safe really are the packages that we are using? Because we have an R repository. We have about 1,000 packages in our repository that we use all the time. We made some of them. We found some of them on GitHub. We got some from cron. Are these packages actually safe? And the important thing for this company was that they work in a slightly, well, not slightly, a very regulated environment, which in their case means that at some point they might actually need to prove this. That someone might come in and knock on the door and say, why are you using this? Why this one? Why not that one? Is this safe? Is this actually something that isn't stealing all the information from the company? They also asked us if they could fix some of the issues. Like some of the software that they were using, some of the R packages were packages that they've used for years. They were used to it. Like I mentioned, some of them made these packages in-house. So is there something that they could actually fix? And finally, the last question was, what is actually out there? Like if we wanted a solution to evaluate packages, what's the state of the art? Of course, we started asking a bit more deep with the questions. We started to ask a bit more, and they kind of just started saying why they wanted to do all of this. They really wanted to just assess the risk of the packages. They wanted to show to their bosses and, again, to audits, to regulation authorities that it was a conscious decision that they picked this that they picked this specific package because it was a good package or it was a safe package. And one thing that was very important for them, because it's kind of what's the state of the art right now, is that they didn't want to use a validated environment. They didn't want someone to go ahead and say, here's a list of packages that you can use. Everything else is off It cannot be used. And again, this was because some of them were in-house. Cron is big. GitHub is out there. If you look close enough, there's probably an R package that does the thing that you want, even if it's lost and is just not well documented. So if you can find that and it does what you want and it can save you hours and hours of development, then why not use it? Especially if you could prove that it's good. So we kind of come up with a list, let's say, of what we wanted to do with them. We knew that we wanted to validate instead of actually prove, instead of providing just a list of validated packages. So they should be able to ask us, could you check this package, please? This was also important for them, which is it needed to be operating system and our version specific, because it kind of doesn't make sense that you're looking at something that was validated in a machine that's completely different from yours. Maybe you're using R 4.0, but the validation was in 3.2. Then it's probably not really up to date. Like, is it actually going to behave the same in your machine while you're working with it as it did whenever it was evaluated? And this is also a problem from the solutions that are out there. Usually they are locked to a specific operating system and our version. They wanted to be able to fix some stuff. So of course, fixing stuff that you did is easy. Fixing stuff that it's on cron is not that easy. But there are still some ways that we can actually help improve, especially when it comes to code coverage. It's actually a very easy process to just inject additional tests into an R package and kind of make the coverage a bit better. And finally, they were very big on trying to contribute or even build on open source solutions. We'll go over some of these, but there are some options, some open source packages out there that kind of help with this process. So how does it actually look out there? So we kind of did a big study and tried to figure out what was out there. The first thing that popped out was Valid R by Mango. Mango Solutions is kind of gone by now, so the actual Valid R program is also kind of gone by now. But it was well documented, and it actually gave us a really nice base of some of the things we could look at. In regulated environments, there's also OpenVal by Autoros. This is more focused and more targeted at pharma companies, but its big problem was that it was a paid service, and it was one of those pre-validated lists. If you wanted to validate your own packages, this would be very, very expensive, and it wasn't something that would just fit their use case. So we kind of started looking a bit more at open source. Risk metric was one of the things that kind of popped out the most. It's one of the packages developed by the R Validation Hub, which is basically just a group of big companies that kind of focus on this stuff. And the more we looked at it, the more promising it became. It was open source. We could take a look inside. We could extend it. We had access to talk with the people that developed it. Unfortunately, it wasn't like a one-to-one solution. And part of this was because of how it was developed. So it was developed as something to be used for regulated industries, which means that making changes to that package was slightly complicated. In our case, we kind of believe that validation is kind of about finding where you actually fit when it comes to risk aversion. This is a nice chart that I stole from Colin at some point when we were discussing stuff. There's kind of a spectrum of risk aversion. And when you're talking about regulated environments, they are extremely averse to risk. It needs to be, everything needs to be as perfect as possible. And this is where things like the R Validation Hub also come in. Their mindset is very focused on these regulated industries. But as you get lower and lower on the spectrum of risk aversion, there's actually a lot of people that would accept a bit of risk. Sometimes during development, it's fine if things aren't great, because when you switch to actually have a production version of your application or of your package, the risk kind of goes away a bit. Or maybe you're just using it internally, and it's fine if it's a bit risky because it never really leaves your machine. And then you can go all the way to the bottom where the risk doesn't matter. It exists on GitHub, fine. It's 10 years old, but it does the thing that I want. It's okay, I will use it. So we kind of have two different sides of the same coin, which is some people really care about risk, some people don't really care about risk. You can also look at this as how much of the environment you actually validate. In regulated industries, you want to validate the entire environment. And this is fine. This is something that technically you can always do. You can validate every single package, and then you can validate it as a collection. On the lowest spectrum, you just validate on demand. Maybe if you really want validation, you just want to validate one specific thing, one specific package. You just want to check the quality of one thing. So how we actually do it is a bit of a departure from what the R validation hub was doing. So the first thing is we did build it with their structure in mind. It is a package that is kind of extended from their work. If you're not familiar with it, so they provide about 20 different tests that test different characteristics of packages. So this can be things like the code coverage, but it can also be the license that's being used. It can be the news. I actually don't even remember very well which ones were the base ones and which ones are ours anymore. But they do have a small battery of tests that they came up with as like a way to kind of evaluate an actual package. So we kind of bumped that up to, I think right now it's about 31 base assessments. Although we do have the mechanism in place where you can just add more. The key word here is flexibility, which is in the case of your specific company, what would be the things that you're the most interested in. If you're not interested in some of the base assessments, that's fine. We can remove them. If you're interested in new ones, we can also add them. We also did a couple more strict things. So we have a very strict installation and dependency check because we really want to make sure that we're testing things in the same environment that you're using while you're working with it. So being specific to the OS, being specific to the R version, being specific to the package version. These are all things that we really, really look at when we're actually doing the assessments. We also do report generation. So this isn't something that RiskMetric offers. It just dumps a data set with all the values, and then you can do whatever you want with it. We went one step forward, so we actually generate some reports, and I'll show you an example of those in a bit. And like I said, flexibility. You can just remove some of these tests, add some new tests. It's completely fine. This is actually just a dump of all the tests that we check in base on our 31 base tests. So you can see there's a couple of documentation stuff. There's some tests are more specific to the code. But we also look, for example, at maintenance. Is the package being maintained? Is it being kept up to date? When was the last time it was updated? But also, are you using the latest version of the package? Because this can also be a bit of a security issue. After we collect all of that data, we can kind of generate. This isn't as nice as a chart, but it still gets the idea across. We kind of collect all of this information, and we can just kind of create a profile of what an R package looks like, and also what things are the most risky about that package. And we kind of generate a score. This score is kind of a confidence score from 0 to 1. So in this case, it measures how safe we feel the package is. This is also something that's completely up to debate. If you would prefer to have something that's based on how risky it is to use something, it's extremely easy to also change. Yeah, we also kind of try to give some information about what are the riskier things when it comes to a package. I think that this is from Threat. And this is kind of the lowest scores that that package hit on our assessments. So while this isn't something that you can do a lot directly, because you cannot really change the size of the code base, for example. If you're a developer and you just created a package and you actually want to improve it, this tells you exactly what things you can focus on. So you created a package, it's on GitHub, your company uses it, it's getting more popular. I need to make this better because, I don't know, IT is complaining. You can look at the list of metrics that are a bit lower and kind of fix things as you go. Okay, so I did promise you some examples. So there's an example report here. I will switch to it, but there's also going to be links on all the stuff if you want to see them. So when it comes to the reports, we're talking about something that looks a bit like this. So like I said, this is for Drat, one of the packages that we use for doing these quite often. And you just have basically an entire report. You have a summary of the assessment itself, so something that you can show IT and say, here's a score based on this platform of assessments. Some information about the environment, some information about what the scores actually mean, and then some more descriptive stuff about each of the categories where you can kind of see what category the package is a bit lacking more. So this also gives you a bit of a thread to kind of fall when you're trying to fix something. And as you go down, it just gets more and more explicit. I think on this specific report, we have just information about each of the assessments, what were the results, and how this affects the risk. And it just goes over all of them. Again, all of this is very customizable, so this is kind of like a baseline report. But if, for example, for you, it's extremely important to have the number of files in a package. This is something that can also be added to all of these. In addition to that, one thing that this report, for example, doesn't have is weights. So every metric is worth the same when it's contributing to the final score. We did find that weights matter a lot. So depending on the client and depending on what risk you're willing to take, some of these metrics might be more, might have a bigger weight to the final score than others. Some of them might be removed completely. Some of them, like for example, I don't know, downloads on CRUN. This might not be really important for you because maybe you work with mostly internal stuff. Or test coverage is extremely important for you because it just shows how, it just shows exactly how much of the code isn't really tested. So maybe you want to have this as a very, like half of the final score or something. Tweaking those weights is something that kind of allows us to find a balance of the things that really matter to you. So this is a Shiny conference, so it would be really mean of me to come here without a Shiny application. So we actually set up a small report for, so I did try to run like the entirety of CRUN on this. I think I managed to get a third of it in the last week. But here you can actually see about, I think it's the first 1,700 packages of CRUN. And it will kind of show you some information about the package and a bit of a detail. So if there's any package that you would like to see that starts with an A, it's most likely here. We'll probably add a few more of these. So like I said, we're kind of running, right now in my house back in Poland, there's a desktop that's running quite a few assessments. Last time I checked, it was up to, I think, 4,000 or 5,000. So these are actually quite fast, especially if you're talking about like 100 packages or 50 packages. It's a really fast process. It can be done even in a day. the whole assessment plus report generation. If you're talking about the entirety of CRUN, this takes a bit longer. But especially when you're talking about 500 packages, this is actually quite a fast process. And this is in a specific machine with a specific R version and a specific OS. So all of this is kind of generated on demand. All of that information gets captured as well in the reports. So when you send this to IT, they cannot say, but you ran this in some random machine. No, it's exactly the operating system that we use, the machine that we use, the R version that we use. If you like this topic and you want to kind of learn more, Astrid is going to have a lightning talk about kind of the structural part of all of this. Do go and listen to her talk. And I think that's it, actually. Thank you. So all the links are here. You can also just take a picture of this. It will send you to all of those.